Ever wondered how AI can condense a 100-page medical report into a one-page summary, or decode the dense language of a legal contract? The answer lies in a groundbreaking technique called parameter-efficient fine-tuning, or PEFT. Let's break it down and uncover why this approach is reshaping AI's ability to master niche domains. Imagine a super smart AI, like a chef who can cook anything from pizza to sushi. But when you ask them to make a delicate soufflé, they struggle. Why? Because they lack specific knowledge, like the exact temperature for baking or the right ingredient ratios. This is the challenge with large AI models. They're great at general tasks, but fumble when diving into specialized fields like medicine or law. Enter PEFT. Think of it as a smart upgrade instead of a full rebuild. Instead of retraining the entire model, which is like overhauling a kitchen, PEFT adds tiny, specialized adapters that teach the AI just what it needs to know. It's like giving your chef a pre-made sauce and a few custom spices. No need to reinvent the recipe. In a recent study, researchers tested 6 PEFT methods, AdaLoRA, LoHA, LoKr, LoRA, OFT, and IA3, on 14 datasets spanning science, medicine, law, and news. They asked a critical question. Can a smaller model like Llama 3.8b outperform a massive one like Llama 370b when equipped with these adapters? Here's what they found. In low-resource scenarios, think rare diseases or underreported news, the smaller model with the right adapter crushed the giant one. It's like giving a compact car a turbocharger. It doesn't need a massive engine to get the job done. But the real surprise: some adapters excelled in specific domains. For example, AdaLoRA nailed scientific papers, while LoKr shined on legal texts. But it wasn't all smooth sailing. Metrics like ROUGE, which checks how similar a summary is to the original, and BERTScore, which measures semantic accuracy, revealed no single method was perfect. One adapter, IA3, had higher perplexity, a measure of how well the model predicts text, but still outperformed others in human evaluations. This means sometimes the best results don't always show up in the numbers. A reminder that AI isn't just about math, but about real-world usefulness. The big takeaway: there's no one-size-fits-all. The best method depends on the task. Let's dive into why. Take medicine, for instance. Datasets like Cord19 or PubMed, vast collections of research papers, showed methods like AdaLoRA and LoRA excelling. Metrics like ROUGE 2, which checks for matching word pairs, and Meteor, which evaluates semantic accuracy, revealed these models weren't just copying text, they were understanding it. Now switch to the legal world. Datasets like YourLex or BillSum. Totally different game. Here, LoHA and LoKr stole the spotlight, with LoKr hitting a jaw-dropping 47.44% on Meteor. That's like an AI summarizing a complex contract with near-human precision. Why did some methods like AdaLoRA struggle? Legal language is a specialized code. The AI needed a more precise approach, which these adapters provided. Then there's news. Take CNN-DM or XSum, where summaries are super short. AdaLoRA and LoRA were still top performers, but results were mixed. In XSum, for example, even the best models barely cracked 30% on some metrics. Why? Condensing a news article into a single sentence is like trying to fit a whole story into a tweet, extremely tricky. But here's the kicker: these results beat zero-shot performance. Ever heard of that? It's like a chef trying to cook a completely new dish without any recipes. Zero-shot models guess their way through tasks they weren't trained for. PEFT isn't guessing. It's learning the right patterns, using metrics like ROUGE and BERTScore to measure quality. This means faster, smarter AI that adapts without massive retraining. So next time you see an AI summarizing a research paper or a court case, remember, it's not just code, it's tailored engineering built for the job. The future of AI isn't about bigger models. It's about matching the right tool to the right task. Thanks for watching, and stay curious, because the next breakthrough is just a few adapters away.